Hi, thanks for coming to my presentation. Aha, okay, we got the remote working now. Okay, so we'll go through a couple of of sections. I'll introduce myself a little bit, then give a little bit of an overview for search. And then after that, get into the meat and bones of ranking. And then after that, a little bit about how our infrastructure at LinkedIn supports this ranking. So a little bit about me. I think, I guess saying it twice now, yeah. So I've been working at LinkedIn on their people search ranking algorithms for the roughly the last 2 years. Before that, I worked at a natural language search type of system at a really small startup, about 1,000 times smaller than the size of LinkedIn. And yeah, I'm from a relatively small, unknown, cold country up north known as Canada. So here is a little overview of search. Let's think about the mission of LinkedIn. So LinkedIn's mission is to connect the world's professionals to make them more productive and successful. And I would have been successful in this presentation at the end if I can convince you that LinkedIn search helps operationalize this mission. So a little bit about search. If you think about what makes the community on the LinkedIn platform thrive, it's people. It's people interacting with each other, connecting with each other, and there's a bunch of ways in which these meaningful interactions can occur. So search drives a large percentage of these types of actions. So some examples if you were to search on LinkedIn for LinkedIn itself, you might find people that you can follow. You might find people that you can connect with. You may find, let's say you try looking up, deep learning on LinkedIn, and you wanted to find groups of like-minded people. You might find a group here that you can join, which is a pretty significant action. And if you tried looking up deep learning people, you may even be able to message them. So these are this is a small slice of. So this is just a small sample of types of actions that overall LinkedIn finds very important for keeping the community alive. Another thing that is useful to know about search at LinkedIn is that we serve many verticals. So I'll give you a quick anatomy of the of search at LinkedIn. You have, as always, the query, which is the textual expression of what the searcher, for example, you may be looking for. We have different verticals here, which are types of results that you might see on the page. So we serve results for people, we serve results for searching posts. If you were to look for groups, we have that as well, and the list goes on. We have documents here, which are the results that appear, and you may have, so documents may include groups, documents may include the posts, and like I'll show you in a sec, they may also include people. If you were to just go on LinkedIn right now and search LinkedIn, we'll show you this thing called the blended search, which is trying to optimize the entire page that you land when you first see the results. So here we have a blend of different verticals. So there's the knowledge card at the top where we think there's a certain entity that you're looking for. In this case, we think that LinkedIn, hopefully, is a company. And we put the knowledge card at the top, which is a link that will take you to the company page. We also have over here we have the people results. That's one part of the blended search, and we also have some posts at the bottom. On the right-hand side, we have these follow recommendations for companies that we think you may be interested in. And then if you were to scroll down, you may even see this type of custom cluster where which involves things that we're experimenting with. In particular here, we are showing you people that talk about hashtag LinkedIn that we think you may be interested in. And this is to help surface, for example, creators. A bit more of the anatomy of people search itself. We have the query, which you might recognize, and then the documents themselves here are simply other people. So when it comes to people search, there are different ways that you can cut it. One way that you can kind of categorize searches for people are whether or not you're looking for a specific person. So if anybody has ever LinkedIn stalked anybody, you've probably done something called a navigational search, which is where you are looking for a specific person. For example, maybe after this, you might search up Mathew LinkedIn, and you might even see a results page that looks like this. If you do that, your intent is to look for a specific person. What's the opposite of that? Not looking for a specific person. In that case, you may just be searching, for example, LinkedIn, and you might just be interested in finding anybody who's relevant without actually trying to hone in on a specific human being. So that's one way that we categorize our searches here. Let's take a dive into ranking. So when it comes to ranking, one of the big parts are the ranking models, and a big part of making the ranking models thrive is having data. A big part of this data is the labels. And here, in order to have training labels, we use clicks to implicitly measure the quality. Examples of clicks are things like clicking on the profile and maybe reading through it to learn more. We consider that a meaningful action. You might click connect to connect with somebody that you find. You may try to message them, or you may even try to follow them. We think that these are all good outcomes of search, and as a result, we try to optimize for these in our rankings. Negative examples here when it comes to feeding our training data is when we show you a particular document, but you end up not clicking on it. We interpret that as you not finding that document as meaningful to what you're looking for. Another part of the models, and by extension, the training data, are the features. So these are the signals that we use in our ranking models. When it comes to search, there are a couple places that you can source these features from. One way is how the query and the document match each other. For example, here, I typed in LinkedIn in my search, and there is LinkedIn in this person's profile. That looks like a match to me, so we consider that when it comes to a ranking feature. Another thing that may be important is how the searcher, who is the person doing the search, like yourself, may overlap with the document that appears in our rankings. So one example here is we may have some social graph-based affinity. Here we have that the searcher and this person who appears here have 51 mutual connections. So that might be an important feature when trying to rank people in search. And then we have a couple other things like document-specific features, such as like a measure of global popularity, or maybe past CTR and stuff like that. When it comes to the overall picture for ranking, we can think of this for search in two stages. Stage one, you need to get the documents, and stage two, you need to sort those documents in some order such that the important things are at the top. Reading from left to right here, we have our search index, which holds all of our documents, which, as a quick reminder, are profiles when it comes to people search. Then the L0 candidate generation is where we retrieve these relevant candidates based on the things that you've typed. We pass this through two phases of ranking, one called the L1 ranker that focuses on how the query is relevant to the document, and then a second ranker that focuses more on personalization. So let's talk about retrieval a little bit so that you can better understand where these documents come from so that when we rank them, it makes a little bit more sense. So first, I type in some query here. For example, Mathew, engineer, LinkedIn. And our query right here is just a sequence of characters. There's no meaning attached to the sequence of characters yet, so we need to attach some meaning to it. We get a tagged query, so the idea is we tag different terms in the query to attach them to real-world entities, hopefully. For example, here, Mathew is tagged as a first name, engineer is tagged as a title, and LinkedIn is tagged as a company. This is important because we generate something that's called the rewritten query, and you can think of this as sort of a set of instructions for the search index to return documents that match these conditions. In a very oversimplified sense, it's kind of like a SQL statement that we go into our database to retrieve documents. A little bit about search indices, if you are not familiar. But a search index in its most simple form is a mapping from a variety of terms to a list of documents that contain those terms. Now, if you think about what a profile looks like on LinkedIn, there are a bunch of different fields. So we take this a step further, and instead of indexing on just the term, we index on the term as well as the profile field that it comes from. A slightly more concrete example of this is I have my first name. In my index, I may store all of the documents for whom Mathew is the first name, and for whom engineer is a current title, and so on. Bringing back our rewritten query, remember that these are just a bunch of conditions that we use to search the index. So we go through our search index, and we look for the documents that meet all of these conditions. In this case, it is documents 2 and documents 2 and 4, and we retrieve these documents and return and send them to the first phase of ranking. So a little bit about our L1 ranking. Again, this is focused on query document matches and general relevance and popularity. The input is 1,000 documents, roughly thousands of documents, and the output we're hoping to pare down to hundreds, and I'll get into a little bit more why. And if you look on the diagram over here, the first step we kind of talked about, the idea is we get all of these documents, assign a score to them using a model that I'll introduce to you in a sec, and then we take the top K of these documents by the score that we've produced, and then send this to our next phase of ranking. Here is, because this is a deep learning summit, here is some deep learning as promised. If we work backwards from this, back propagation style, you'll see that this score here is the thing that we ultimately care about. How do we produce the score? There are two types of features that we care about when it comes to our ranking. There's this notion of deep features and wide features. Deep features come from embedding type inputs. So the idea is we have the query, we pass this query through some CNN type of embedding, and we also take profile texts from the document and produce embeddings for those as well. You can imagine that things like headline and title and skills in other fields may be predictive as to whether or not your query is relevant to the document. So we get embeddings for all of these. We compute a cosine similarity between these embeddings, and then we feed that as an input to a multi-layer perceptron. The wide features, on the other hand, is just a fancy way of saying numeric features. Some of the things that I talked about before, like number of common connections and things like that, might appear in this wide features vector over here. So after we've concatenated all of them, those go through a couple more layers, and out comes the score. That was the L1 ranking. As a recap, our input was thousands of documents, and our output is hundreds of documents. This is important for L2 ranking because the L2 ranking is a little bit more expensive. So we'd like to make sure that we have a short list that we do the ranking, that we do the scoring on. In this phase, we focus more on personalization, i.e., what is the searcher's intent, and the embeddings are, again, from a BERT model. So another deep learning diagram. If you see commonalities between this and the thing I showed you a minute ago, we'll get to that in a bit. But to unpack this a little bit, again, starting from the score, the score is the output of a couple of hidden layers, and again, we have this deep features and wide features type of paradigm again. The way in which this is different is that the deep features come from embedding more types of fields. So we embed the query like before, but this time using BERT. We embed parts of the searchers. So, for example, if you're doing the search, we would embed text from your profile, and then we also embed the we also embed again the profile text found on a given document. So the main differences here are we're using BERT for the embeddings, and now we're including text from the person who's doing the search as a way for accounting for intent and personalization. To give you a bit of a comparison, what impact does L2 ranking have? With L2 ranking, I get personalized results if I look for LinkedIn. The people who appear here, I promise you, are my coworkers and my teammates that I just haven't added yet. And if I were to disable L2 ranking and only use L1, the people who appear are more sort of generic results, sort of popular people who happen to match the thing that I typed. So hopefully this convinces you the role that L2 ranking plays. Like I mentioned before, our ranking paradigm between L1 and L2, plus minus some textual and architectural and some deep learning differences, is roughly the same. The ranking framework that we use actually is open source. You can find it under this URL over here, and it's called dtext. So unpacking this a little bit, we have this text interaction layer, which takes in embeddings from, say, the query and from other document fields, and these interactions get passed up to our multi-layer perceptron layer, which also takes in all of these other numeric features. This is the deep learning here is advantageous compared to what we had before, because our past models using things like XGBoost were only able to do literal types of matches and couldn't really model these interactions like this. So with the remaining time that I have, let's talk a little bit about the infrastructure that supports our deep learning models. So starting from kind of the MLOps side, we have an internal MLOps stack called ProML, which stands for Productive Machine Learning. This manages things such as online and offline features, and for training models, versioning models, getting these deployed and published, as well as being able to monitor them as they do their thing in production. There's on the actual search infrastructure side, we have something that's called Galean, which is you can think of it as a descendant of the open source Apache Lucene. To unpack this a little bit, the user, such as yourself, may make a query. It goes through the search front end and then calls all this stuff in the back end. So the idea is the federator fans out to a number of different verticals. One of these verticals will be the people search vertical. And we have a broker here that merges the results that are returned from the searcher, which is another way of saying that we shard our index. So giving you a visual on this, the L1 ranking happens over here. So we retrieve documents across our different searcher shards, and we score those documents all in parallel, and we merge those results in the broker, and those merged L1 results get returned or get sent to L2. So the L2 ranking happens in the federator, and for example, some of the things that we use here is this library within LinkedIn called Quasar, which helps manage the pre and post processing of some of the features and the scores. So yeah, that's pretty much it. Hopefully, I've convinced you today that that search operationalizes LinkedIn's mission. The search at LinkedIn serves a variety of different intents for a wide variety of different content. Providing a universally good experience for people's search system is a challenging problem, and that's kind of where we get some of this complexity from. And yeah, deep learning as well as data sort of have an equal part in how we do with our personalization. So so thank you for listening to my presentation, and if you have any questions, let's get started.